Hello and welcome. In this series of videos related to UPSC Basics, today we will be discussing about PSLV or the Polar Satellite Launch Vehicle System. This particular topic is important for GS Science and Technology, PT and Mains. This particular video would discuss about the basic design of PSLV, the basic variants of the PSLV, the launch systems of the PSLV and the significance of PSLV. PSLV or the Polar Satellite Launch Vehicle System, which has been taken up as the workhorse of ISRO or the Indian Space Research Organization, is one of the most popular, most reliable, most reputed and most deliverable system which ISRO has developed. This particular system, which is in service since 1992-93, has been developed to launch polar satellites. This is a particular satellite system or launch system which has been taken up as an expandable launch system. When we say expandable launch system or launch vehicle systems, expandable launch vehicle systems are those which can have various different variants according to the payloads and according to the distances which are to be traveled from surface of the earth. That means this particular launch vehicle system PSLV can carry different types of the weights, can reach up to different types of the orbits, can also take up different types of the launches as well. So it becomes an expandable system. It is also a medium lift launch vehicle system. When we say medium lift launch vehicle system, then all those launch vehicle systems which can carry 3000 to 3500 kgs of the payload into the lower earth orbits or geosynchronous transfer orbits are being taken up as the medium lift launch vehicle systems. For all those systems which can carry more payload, more weight, which is around more than 4500 kgs of the weight, they are being taken up as the heavy lift launch vehicle systems. India right now has two major launch vehicle systems. One is PSLV, another one is GSLV. Both of them are medium lift launch vehicle systems. So PSLV is a medium lift launch vehicle system. This particular launch vehicle system is being designed to launch satellites which are polar in nature or which are being placed in polar orbits. When we say polar orbits, are all those orbits which are perpendicular to the equator or at a perpendicular direction to the equator. These satellites, precisely they are being taken up for earth observation, for imaging, observation, spy, etc. The polar satellites, they are being utilized. So PSLV was initially procured or PSLV was initially designed for the Indian remote sensing satellite systems, right? And later on, as the requirements or the needs or the missions have expanded with ISRO, PSLV has delivered for various other missions also, mainly Mars Orbiter mission, Chandrayaan mission. Anywhere we say PSLV has delivered, so it has become the workhorse or the most reliable launch vehicle system also. PSLV, when we say, or if we look up to the basic specification of this particular launch vehicle system, this is a 44.4 meter long launch vehicle system which is 2.8 meter wide in its dimension. This particular launch vehicle system is a 4-stage launch vehicle system where solid, liquid, fuel are being filled. This particular launch vehicle system can take up multiple objects or the multiple spacecrafts into the space or multiple satellites into the space and can also target multiple orbits at once. So maneuverability is high, expandability is high, as well as reliability is very high with this PSLV. So 44.4 meters of the diameter, 2.8 meters, 44.4 meters of the height, 2.8 meters of the diameter, 4-stage vehicle, multiple satellite launch capabilities, multiple orbit capabilities, right? Came into being in 1993 and it has a capability of carrying, or the complete mass of this particular launch vehicle system is 320 tons. Now the basic payloads that we can look up to PSLV that can be carried is 3800 kgs can be carried into low earth orbits. Now when we speak about the low earth orbits or LEOs, low earth orbits are those type of the orbits which are closer to the surface of the earth. These are those orbits which are placed at a distance 200 to 2000 kilometers above the surface of the earth. Now precisely most of the satellites which are either the observation satellites or those type of the satellite systems which are the earth stations also, or satellite stations also, or imaging satellites. Most of these satellites, they are being placed in low earth orbits. So precisely PSLV becomes an important rocket system over here, because it can launch all those satellites which are important either for earth observation, imaging, or creating an earth station also. Apart from this, other payloads that can be carried up with the PSLV would be 1750 kgs can be taken up into the sun synchronous orbits. We'll discuss what are sun synchronous orbits also. Or 1425 kgs of the payload can be taken. That now this payload is the weight of the satellite or the spacecraft that this particular launch vehicle system is carrying. So it can carry 1425 kgs of the payload into the sub-GT or the geosynchronous transfer orbits, or 1300 kgs of the weight into geosynchronous transfer orbits also. Now if you can look up to these orbits also, apart from the low earth orbits that we have, which are 200 to 2000 kilometers above the earth's surface, which are being created for earth observation and imaging or the earth stations. Apart from this, the geosynchronous transfer orbits, these are those type of the orbits where the overall orbit act as a transfer path, where any object can be left in these orbits and it can reach up to the geostationary orbit. Now geostationary orbits are those type of the orbits, or the geosynchronous orbits are those type of the orbits which are being placed at 36,000 kilometers above the earth's surface approximately. Now when we look up to this, reaching up to 36,000 kilometers above the earth's surface at once is something which is not quite possible for any launch vehicle system. So most of the launch vehicle systems, they create certain defined paths using which the objects or their altitudes can be raised continuously. So these type of the paths, they become the transfer orbits. Now geosynchronous transfer orbits are those where objects can be placed and can be raised to distances which can be 36,000 kilometers above the earth's surface. The geosynchronous transfer orbits, they they will have a perigee, or the closest point from the earth in the LEO, which is nearly 200 to 2000 kilometers. Mostly the PSLV uses a perigee of 600 to 800 kilometers over here, or it can transfer the object between this particular range, that is 600 to 800 kilometers above the earth's surface. These are those type of the orbits where the apogee is as high as the geosynchronous orbits, or the geosynchronous orbits which are being created at 36,000 kilometers above the earth's surface. Now using these geosynchronous transfer orbits, objects can be easily placed into the higher orbits also. So it can place objects which is near to 1400 kgs into geosynchronous transfer orbits or sub-geosynchronous transfer orbits also, which is nearly 600 to 660 kilometers above the earth's surface also. The other type of the orbits which can be taken up by PSLV are the sun synchronous orbits. The sun synchronous orbits are those which are precisely again created at 600 to 800 kilometers above the earth's surface. And these are those orbits in which if any particular object is being placed in these orbits, the alignment is so that the angle between the object, earth, and the sun always remains constant. So around the year, the objects change their revolution in such a way, that the sun angle always remains constant. So they always remain synchronous to the state of sun, or the amount of light which would fall over such type of the object. So it becomes a sun synchronous orbit also. Sun synchronous orbits are mostly polar orbits, or these orbits are mostly perpendicular to the equator as well. So when we look up to sun synchronous orbits, they are being used for imaging, spy satellite systems also, and mostly the Indian remote sensing satellites, they are being placed in sun synchronous orbits so as to maintain a constancy in observation also, which is at 600 to 800 kilometers above the earth's surface. So PSLV can place objects into these orbits also. Now when we look up to the overall design system of PSLV, this is the basic design of PSLV, and PSLV design is more important to understand. Now, when we say PSLV as a design itself, PSLV is a 4-stage rocket system. When we say 4-stage, we mean 4 different types of the fuel systems which are being utilized over here. PSLV is a 4-stage rocket system in which the lower stage is solid, then we have the liquid stage, which is the second stage, then we have a solid stage, then we have a liquid stage again. These are the 4 different stages which are being utilized in PSLV. 4 different types of engines, you'd say, or 4 different chambers of 4 different types of the fuel. Now, PSLV or the solid fuel for PSLV is always HTPV, which is the derivative of hydroxyl terminated polybutyrate, which is a derivative of gunpowder or gun material. The liquid fuel for PSLV is initially UDMH or unsymmetrical dimethyl hydrazine, and the upper stages it is monomethyl hydrazine, MMH, which is being used. These are the propellants which are being used in PSLV. These are the type of fuels which are being used in PSLV. Now, when we look up to PSLV 4 stages, the initial stage is the solid fuel stage. The solid fuel is being placed in the core engine. This is the core engine that you can see. The core engine is surrounded by 6 different types of the motors, or 6 different types of the boosters. These are called as the solid strap-on boosters or strap-on motors, or primary strap-on motors also, PSOM. Strap-on motors because they are loosely binded to the core body. These are filled up with the fuel system itself, the solid fuel system itself. Different variants will have different amount of the fuel which is being filled up in these boosters. 9 ton or 12 ton is the basic quantity of the fuel which can be placed in these solid motors. Then you have the core motor, which is S139 motor or the S139 fuel system motor, which will have 138 tons of the solid fuel which is being placed. Together, these two would create the primary state or the first stage of the PSLV. Now, out of these 6 strap-on boosters that we have in PSLV, 4 strap-on boosters, they are being lit on ground itself, right? They would be lit on ground along with the core system. They would be fired on ground itself. Now, rest 2 strap-on boosters, they are being lit or they are being fired 25 seconds after the launch of this particular vehicle. So they last longer, right? The 2 strap-on boosters. So strap-on boosters and the primary core, which is S139, which would contain 138 tons of the solid fuel. Primary motors would contain 9 ton or 12 ton of the solid fuel. Together these, they run across, and they run across for 110 seconds, right? They run across for 110 seconds. The strap-on boosters run across for 70 seconds. The 4, they would run across for 70 seconds, and then additionally after 25 seconds 2 strap-on boosters would also come in. So the total run for the core and the strap-on boosters reaches up to 110 seconds. For the initial 110 seconds, this particular fuel is being burnt, and this gives the basic thrust. Now, any rocket system is being placed or is being based upon the basic mechanism of Newton's third law of motion, action and reaction. The amount of force which is being pushed by the rocket system, the equal amount of the thrust is being gained by the rocket system to go up into the sky or go up into the space. So over here, the solid fuel system, it will help in providing the upthrust, the immediate or the impulsive upthrust, because it would be a kind of explosion which is being created over here in the solid fuel, and gives an immediate impulse or upthrust for this particular launch vehicle system also. Say after 110 seconds, once this particular thing or once this PSLV has achieved its state like this, it is being launched, and it reaches up to the 6 strap-on boosters or the 6 strap-on motors. They are being separated apart from the main or the core engine. The rest of the at 70 seconds, the 6 strap-on boosters or the 4 strap-on boosters, they would be separated. After 25 seconds, rest of the strap-on boosters, they would be separated, and the core would also come in. The first core also would come in. So in this way, it is being uplifted and at say 110 seconds the first strap-on booster is being, or the solid fuel core is being separated from this particular rocket system. Now for the separation of this rocket system, there are retro rockets which are being placed over here. Retro rockets are those which would fire in an opposite direction. This helps to open the core. This core is being opened over here. The solid and the liquid, the solid core is being separated over here. This separation is being taken up by jetsoning of the retro rockets over here. So we have 8 retro rockets which are being placed between first and the second stage. Now then comes the second stage of the PSLV. Second stage, which is liquid fueled stage, which contains UDMH, unsymmetrical dimethyl hydrazine, as the basic propellant, and nitrogen tetraoxide, which has been mixed over here with unsymmetrical dimethyl hydrazine. This particular second stage, or the second stage of the PSLV, is being fired for another 133 seconds. After the 133rd second, the PSLV second stage is being separated, and then the third stage comes over here, which is again a solid stage. This is liquid, this is solid, this complete is solid, then this is liquid, then this is solid, which would again contain HTPB, or hydroxyl terminated polybutyrate. That runs for around 83 seconds over here. So 110 seconds for the initial one, 133 seconds for the liquid, 83 seconds for the third stage solid. Now afterwards, once the fuel is being exhausted, or it reaches up to a desired height also, which is around 300 kilometers above the Earth's surface, the third stage is being pulled apart from this rocket system, and the fourth stage, which is the liquid again. This is the fourth stage over here, and then over here we will have the spacecraft also, which is being placed. So the liquid stage is being turned on, which runs for 425 seconds. This is the longest that a particular launching system or the fuel system is being utilized over here. These are throttled fuel systems also. Throttle would mean that these engines can be turned on and off according to the requirements also, because at the upper stages of the rocket launches, the amount of upthrust which is being required lessens down, although there is gravity, but the immediate upthrust lessens down, and in the space the object can move according to its trajectory also. So there could be a throttled engine which can also be utilized over here. These are liquid throttled engine. Now over here, specifically in the second stage, the engine which helps in burning up of the liquid fuel is being specifically designed by India, which is the Vikas engine. Vikas, which is the name which is being given on Vikram Ambalal Sarabhai, is the indigenously developed liquid propulsion engine of the launch vehicle systems in India. It is being utilized not only in PSLV, it is also utilized in GSLV, the Vikas engine. So if you look up to the Vikas engine over here, then this is the basic design of the engine for the second stage, which is the Vikas engine, which is being utilized for liquid propulsion in PSLV. Now this is a family of liquid fuel rocket engines also. It is being designed using the basic designs of the Viking engine of France, right? And based on the chemical compositions or the chemical mixtures which are available in India, this particular engine system was being created or developed, demonstrated, and later has been utilized exhaustively in most of the launch vehicle systems in the country, be it be PSLV, be it be GSLV. The Vikas engine is the most important liquid propulsion engine which is being utilized. It produces around 800 kilonewtons of the thrust, or 80 tons of the thrust can be taken up over here, right? And this engine also maneuvers easily as well, right? This engine utilizes around 40 metric tons of the unsymmetrical dimethyl hydrazine, which is the basic liquid fuel which is being utilized in the launch vehicle systems. There are multiple variants of Vikas engine, which is Vikas 2, Vikas 2B, Vikas X, Vikas 4V, which are being utilized in different launch vehicle system, be it GSLV, GSLV Mk3 or PSLV, different variants of the Vikas engine has been utilized, which is again one of the most important engine systems which is being developed by ISRO, or the liquid propulsion system also. Now, the liquid propulsion system is also coming up with the throttleable Vikas engine also, which can be turned on and off continuously during the flight according to the amount of upthrust which is being required by the rocket system or the satellite system, which will help to increase the total amount of the upthrust gained by this Vikas engine, also the amount of force which is being gained, or the amount of the duration for which this particular engine can be run through also. That would also increase, and the distance that can be covered using this particular engine would also increase. That would become the throttleable Vikas engine. Recently, the ISRO has taken the hotbed test for the throttleable launch vehicles, throttleable Vikas engine as well. So that would be the future discussions also that would come in. Coming back to the basic design of PSLV again, PSLV will have the solid liquid. Apart from these, it also has certain cylinders which are being strapped along with the PSOM, or the primary strap-on motors also. These are the secondary injection thrust vector control systems, SITVC. These are those systems which are being utilized in maneuvering up of the launch vehicle system. These cylinders, they contain ammonium perchlorate, a kind of component or a chemical component, which is being released using many ring-like structures which are being placed between the core and these cylinders. When they are being released, the exhaust which is coming out of the engine, the direction of the exhaust can be changed. So either we can increase the exhaust over this side, or we can increase the exhaust over this side. If the exhaust is increased this side, the launch vehicle would go this side. If the exhaust is increased this side, the launch vehicle would go this side. In this way, maneuvering of the PSLV can also be done using the SITVC, which is the primary thrust vector control, or we can say the secondary injection thrust vector control also. Apart from this, roll, pith and yaw of the launch vehicle system, roll, pith and yaw of the launch vehicle system is also being maintained. In second stage, the hot gas reaction control motor is being placed, which is a kind of maneuvering motor which is being placed with the second engine itself, or the second state itself, with the Vikas engine itself. And there is a toroidal tank which is also being placed over here at the end of the Vikas engine. If you have the Vikas engine over here, then there would be water tanks which are being placed, and then we'll also have the hot gas reaction control motor which is also being placed over here, which again helps in pith and yaw control of the launch vehicle system, or maneuverability of the launch vehicle system also. So some part of this launch vehicle system, or during its flight, its direction or the flight can be maneuvered easily also, right? Apart from this, in the upper stages, the upper liquid engine stages, or the throttleable engines, the engine gimbal would be where engine can move on its axis according to movement of the engine, or according to the axial movement of the engine. The maneuvering of the launch vehicle system can also be created. So these are some of the important aspects relative to PSLV: solid liquid, the retro rockets, the jetsoning of this, then the Vikas engine, the liquid engine which is being created. All of these are some of the important points related to PSLV. Now, the upper stage of PSLV, the upper stage of the rocket itself, when we speak about, is the payload fairing, or the heat shield which is being created. The uppermost knob, or the nose of the rocket system, is being created in two different halves. Inside these halves, these spacecrafts are being placed, right? These halves, they separate as they reach up into the space. They are being aligned together when they are being launched, aligned together to create the nose of the PSLV. After the second stage of the engine, or the second engine turns off, that is the liquid engine turns off, or the Vikas engine turns off, and it gets separated. At the same point, the payload fairing also gets separated. It opens up and gets separated over here. So this is also one of the important aspect of PSLV, right? So in this way, if we can look up to the basic launch of PSLV, PSLV is launched with all its strap-on boosters. Then strap-on boosters are being opened first. Then the first stage rocket is being separated, or the first stage core is being separated. That you can see the retro rockets, they are being pulled upon. Then the Vikas engine starts to fire. Then the Vikas engine keeps on firing, and at this point the payload fairing is being removed over here. If you can see the payload fairing over here and over here, the payload fairing is being gone. At the ignition of the second phase itself, the payload fairing is gone, and the rocket reaches up to the terminal stages also of its flight. Next, if we can look up to, then the second stage has been fired, the Vikas engine comes out over here. The third stage separation also comes over here, where the solid motor is being exhausted and gets separated out. Then the fourth stage motor gets separated out, and with the spacecraft or with the satellite, we have throttleable liquid propulsion engines which are being created for its movement, pitch, yaw, maneuverability, and also for a slight amount of the flight change can also be driven with the help of satellite liquid propulsion jets itself, where it can maneuver itself, satellite. And in this way, the satellite is being launched, the solar panels open up, and the satellite is launched in the orbit system itself. So if we look up to the overall flight of the PSLV, then PSLV, if we can look up to over here at 110 seconds, at 70 seconds, the PSOM comes out, or the primary strap-on motors comes out. Then around at 110 seconds, the first stage comes out. At around 162 seconds, the payload fairing is being taken up, the Vikas engine is being turned on, and then at around 262 seconds, the Vikas engine comes out. At around 495 seconds, the third stage comes out. At around 505 seconds, the fourth stage comes out, and then the object is being placed, or the spacecraft is being placed into its orbit. In this way, the PSLV launching system has also been created. If we can look up to the various variants of PSLV again, then there are 5 major variants which have been utilized in different flight systems. The first one is PSLV-G, which is PSLV generic that we have discussed about, 4-stage motor systems, 6 strap-on boosters, 9 ton of the fuel in these strap-on boosters, solid liquid, the basic generic version that we have spoken about. The second one is PSLV XL, or the extended version, where the strap-on boosters, they are elongated. Now this is not the 9-ton strap-on booster, this becomes the 12-ton strap-on booster, which is being involved with the core motor over here. So it becomes a 12-ton PSOM which is being taken up in XL. So the launch capability and launch duration also increases over here with XL. Then we have the PSLV DL, where we have only 2 strap-on boosters, not 6, rather 2 strap-on boosters, both of them of 12 tons. Then we have PSLV QL, DL would be 2, QL would be quadra. So we will have 4 strap-on boosters, all of them would be 12 tons of the fuel. We also have PSLV core alone, which is also being used, core alone, in which no strap-on boosters are being seen, no strap-on boosters, only the SITVC control systems, those tanks which contain the ammonium perchlorate solution are being placed over here as a strap-on thing. So it becomes a core alone thing, depending upon different type of the payloads, right? The generic can launch up to 1678 kgs to sun synchronous orbit, that is up to 600 to 800 kilometers. XL can launch up to 1800 kgs of the payload to 600 to 800 sun synchronous orbits. Then PSLV DL can launch 1257 kgs of the payload, around 1250 kgs of the payload to sun synchronous, whereas the QL can launch 1523, more than the DL version, into the sun synchronous, and the core alone can only launch 1100 kgs of the payload into the sun synchronous orbit. So depending upon the type of the strap-on boosters, which also increases the expandability of this particular rocket system. We have the first thing that we have seen about PSLV is that it is an expandable launch vehicle system. Why it is expandable? Different variants on the same design, solid liquid design system, but based on these strap-on boosters, and that's why these strap-on boosters are also being created according to the payload, according to the distance to be covered. Strap-on boosters can be increased and decreased, the upthrust can be increased and decreased, and so on. The expandability of this particular rocket system can also be created. That's why PSLV has different variants based upon these strap-on boosters or these strap-on motors that are being created. Then if you look up to the basic significance of PSLV in today's world, PSLV is something which has created more than 55 plus launches, rather precisely 57 launches it has taken till date, right? It had only 2 unsuccessful launches in these 56 launches, and 1 partial unsuccessful launch also, which was taken up. It is workhorse, it is consistent, it delivers every time. It has been globally recognized owing to the various tedious missions that it has taken up, specifically missions like Chandrayaan, Mars Orbiter mission, Astrosat mission. These are all taken up by PSLV. We didn't have GSLV for these missions. So PSLV was there and PSLV has delivered. So it is recognized globally also. It also had the pivotal role in launching the satellites for Indian remote sensing satellite system, NAVIC system that we have right now, the Indian GPS system. Majority of it has been, or in fact all of it has been launched by PSLV only. It has also created remote sensing satellite systems, the IRS 1, 2 and 3 series, they are all being taken up by PSLV. Earth Observation Satellite System, CATOSAT, ResourceSat, etc. All of them, they are being taken up by PSLV. Then it is one of the best mid-lift launch vehicle system owing to 3 things. It has a simple design. It also has a cheap cost, is not that much costly, easy to assemble also, and the assemblage time is also lower compared to other medium lift launch vehicle systems that we have. It has less complex design, it is cost effective, it has effective maneuvers, and it has dog leg maneuvers also, where it is more important. So this is the basic significance of PSLV, and that's why PSLV is so important for us. So understanding the basic design of PSLV can be important. Different types of the questions they have been asked, like for example, if we can look up to the PT based question, where with reference to India's satellite vehicles, consider the following statements. And the first statement is about PSLV. PSLV launches the satellite useful for earth resource monitoring, whereas GSLV designed mainly for launch communication satellite. Rather, it is correct. Satellites launched by PSLV appear to remain permanently fixed in the same position. Rather, it is incorrect, because these are those satellites which are geostationary satellite, and PSLV does not launches geostationary satellite. GSLV Mk4 is a 4-stage launch vehicle system. Rather, it is a 3-stage launch vehicle system which is being created. So based on the basics itself, the questions are being asked in UPSC. Now, based on this particular basic discussion also, a question can also be asked in mains as well, where we can say what is the basic design of PSLV, or what is the basic significance of PSLV for ISRO, because the PSLV has been into news due to the new generation launch vehicle system which has been announced by ISRO, and that new generation launch vehicle system would replace PSLV. So PSLV would not have more of the flight in the next 4 or the 5 years. By say next 5th year, PSLV would be retired also. So PSLV is something which is important right now, is into news also, would always remain into news, is something which is basics of space technology. That's why it is more important. I hope this video was learning method for you. It would have solved various doubts relative to this particular topic. I'll try to come up with more videos over these basic topics also in a simplified version also. Thank you very much for your patience.